recording. Oh, I didn't know if it was already recording because it had a little circle.
Now it's recording.
Yeah.
So this is section 7.4, arc length and surface area. And today, at the end of this lesson, you'll be able to measure the arc length on a function and measure the surface area of a solid of revolution. Let's begin. Okay, so to derive the formula for arc length, we've already talked about it with the warm-up. It's basically just doing a lot of little teeny tiny Pythagorean theorems, right? So here we've got that same curve from warm-up. It's just root x from 0 to 2. And the first thing that you do is you approximate the length of a single arc. You don't have to write this down. This is not going to be tested on. This is just how you derive the formula, in case you want to know. So this is just Pythagorean theorem. It's if our change in x, delta x is here and delta y is here, then it's that squared plus that squared equals our length squared, right? So that would be the length of a single arc. What you do next in order to get the formula is you pull a root x squared, the square root of that, out of each term, or I'm sorry, not root x, a delta x, and you end up with the delta x out front, and then you get 1 plus delta y over delta x squared. So what does delta y over delta x make you think of? dy dx, right? Which in our world means derivative, right? So believe it or not, we're going to have the derivatives in our integrals. So we have, if we, excuse me, so if we get this, that's again just the length of one arc. And in order to get it to be more exact, what we do is we take the limit as those delta x's, the width approaches 0, right? And then we add. So that would give us the length of a teeny, teeny, tiny arc. And then, of course, we have to add all of them together to get the full length of the arc. So we've got this lovely formula. So our delta x, when we take that limit as delta x approaches 0, becomes dx. This becomes dy dx. And the formula ends up being there we go. Arc length, ta-da! Okay, so arc length is the integral from a to b of the square root of 1 plus f prime squared dx. So it's kind of weird to have a derivative inside of an integral, but we're going to be using this all day. Is that okay, Mary? It sounded exasperating.
No, I was just like,
Okay.
just well, I would see the video. Feel free to call on her some more.
Clear as mud.
Clear as mud.
Because mud is not clear. Just gotta
All
throw
right.
me off.
So, to find the length of the problem that we did as the warm-up, root x from 0 to 2, everyone see if you can set it up using the formula.
Let's go, Hannah.
Do it in my head. Keeps giving me a flashing battery, so I don't know if I should just stop it and save it, or...
Let it run until it completely dies, and then I'll charge it to me.
Will it save still?
I think so. If it doesn't do it, it's okay. We'll just start recording all tomorrow.
Prime material.
Having fun with the Zoom.
Oh, this is your warm-up?
I really want to record people, but I can't.
Let's see.
So instead I'm just basing it.
That's beautiful. Yep. But now just use the formula and don't make it quite so complicated.
God, my laugh's going to be on this.
No, I just.
All right, does that need another second? Looks like some people are still working. Okay. That's up to you.
Oh my god, my leg. I'm tired. There we go.
Your foot's gonna be in it.
It's not in it.
Does everyone have at least a setup? All right, so what are the limits? 0 to 2. Square root of 1 plus, what's the derivative of root x? 1 half x to the negative 1 half, and then we square it. It's been a while since we've done derivatives, but they should kind of feel like old friends, right?
Sure.
Yes. Derivatives to me are it's like a comfy blanket. You just, they're happy things to go back to. Are there any questions on this one? Shall we take it up a small notch?
But even if we say no, you still will.
Yeah, that's true. The next one I've got to erase really quickly. So, actually, you know, I think I'm just going to put the shades down. All right. So, we're going to try to do these integrals no calculator. The first one is extra fun. The second one's not so bad. But tomorrow is all integral review. We are doing massive integrals tomorrow. Your test is more than half just integrals, again, just like your chapter 5 test, right? The first 2-3 pages are all just integrals, right? So we are going to be reviewing integrals that we've learned so far tomorrow so that Wednesday we can learn all new ones, right? And add to that inventory of integrals, yes. Okay. So anyway, but I want you to find the length of, this is x cubed over 6 plus 1 over 2x from 1/2 to 2. When I'm doing these, the first thing I always do is just find y prime. And then I do my integral setup. Even though a camera's running, you can still talk to each other.
Okay, we don't talk to each other anymore. So.
Stop.
You can also call me over if you have questions or want to help.
Yeah.
You coming tonight?
Who do we? Yeah, of course I am. I have
We
this.
play Orno in the EP team. Poor girls. We're gonna crush them.
I was gonna say a name, but I don't want the name to be on the video.
It took me a minute of thinking to get it.
You know who's on that team, right?
On what one?
EP Orno? EP3 Orno? No.
She's the only EP one that's gonna be there because of all the 8th graders are
I thought there was one
maybe
from
one girl.
JV that was on there. She was one of like the Asian ones, but maybe it was either Katie or Haley, but I couldn't remember which one was which.
It's definitely Katie.
Where's Miss Price? I really want to zoom in on her face.
She's right there.
I can't. Can you just go stand up in the room for a second?
Stop.
What are you doing? Don't like zoom in on my face.
Too late.
All right, did you all get the correct
She just went up
derivative?
there.
1/2 x squared minus 1 over 2x squared. Or you can do 1/2 x squared minus 1/2 x to the negative second. Right? I went ahead and just put them all over 1 LCD. I don't know. I honestly, when I was doing this the first time, I don't know if this was the easy way or this was the more roundabout way. I solved it, but who knows? Maybe it was easier to not do this. Anyway, all right, so you plug into your formula. AL, it stands for arc length, right? Okay, so 1 to 2, 1 plus this squared, right? And then I'm looking at this and I'm like, I'm just not sure what to do. So then I went ahead and found an LCD for the whole thing, which I still don't know if that was the easiest way to go or not, but that's what I did. Squared out that term and then combined like terms. That's an 8, by the way. And then I realized,
There's a blob.
hey, look at that. This top part, factors.
No way.
Way. Right? So this ends up being an x to the fourth plus 1 quantity squared. And then I was looking at it for a second, and then someone in third period said, oh, and then you can square root. And then you can square root, right? So you square root, and now you've got a nice, simple integral. It's really not so bad.
And is this typically the difficult level you would say these questions are going to be?
I don't know.
Okay.
Yeah.
Thank you.
Okay, so there you go.
Oh, in church, I heard that
Right?
once. This is the
Now,
easy.
what would you do from here
Integral.
to integrate this thing?
Gotta find
No
the
idea.
antiderivative.
No idea? When you have a monomial on the bottom,
Divide it.
divide each term, right? Just treat it as two separate terms. So you divide each term,
Smiley face.
and you get that. That's what we have. Right, and now it's just bam, bam, do power rule. It's hard to believe that this became that, right?
So hard.
Yes,
How do you get
Claire?
from the step, middle left to the one next to it?
From
Yes.
here to here? Oh, I took the square root of the top and the bottom.
Oh.
I know, yeah, I know. That was the light bulb moment for me too. Yes.
Okay, good. Yeah, yes, yes, okay, yeah.
Well, it's not mine. So it's the exact same thing.
And now it's gone.
What's the, what's
Then you just have a little bit of arithmetic to do with the denominator of 48, right?
Oh.
she had an answer like
Did you on purpose have this problem, or did you just write one and then nothing? You're like,
Usually I pass. I know
Yeah.
you guys.
Yeah, second option. Yes,
okay.
yep. But I stayed with it. Having some difficult problems is not always a bad thing.
Sure.
Now, the next problem, and did you guys notice
No, we're
the
still
formula for the
going.
arc length is like the easiest part, right? So like the fact that it's an arc length problem isn't what makes it difficult, it's just a tough integral, right? Okay, so the next problem, let me put on a new shade.
Stop. Well, if we just whisper, stop, just stop. Stop.
There we go. All right, so for the next problem, find the length of y minus 1 quantity cubed equals x squared on the interval from 0 to 8. When I worked this one, and you can do this certainly with a dx and it's fine, except that it's really hard to integrate. So if you solve it for x in terms of y and do a dy, then it's really a fairly simple integral. So I'd like you guys to take a second, solve it for x in terms of y, find your derivative, square it, plug it into the formula, and then there's a little hint, don't forget that if you do this as a dy, your limits need to be y values. So give it a shot. Okay. Yep, do this one by hand too.
I was Cuban something.
How's that camera doing?
Good. I was setting it down for partially a second so I can actually think.
So I really could have just set it on a desk. and
Not
tilt it.
really, because I have to tilt it up.
I could prop it on a book or something.
Yeah, you could. Still fun though.
Would you like to sit and resume writing and I will prop it on a book?
No, I like this.
If you're honest.
All right, did you guys select for X? Did you find X prime?
Oh my god.
Are you gonna find the integral here?
It keeps, every time I breathe, it goes up and down, so I try like not to breathe too much.
That was a sneeze. That was the quietest thing ever.
Can I give you a hint? If you do y minus 1 cubed, yeah.
Mine always change when I'm sick. They just sound terrible. When I'm not sick, it's just like, chew. It's like, quit sneezing like that.
You're like, sorry,
Sneeze
I'll
like,
stop.
no, I tell myself that. I'm like, sneeze like a normal person.
You are even more distracting you. You and your head on your desk. All upset because of your little embarrassing moment. It wasn't even that bad.
Because you have to be treated. I would rewrite his 3 house.
I really want someone to say one of those things on the wall just so I can go zoom in on it. This is just too hard, Miss Price. I don't think there is one of those. Oh, it is. Mena's putting up one tomorrow.
She is.
Yeah, we're making one. It's.
Is that what she's doing right now?
Oh my god, wait, hold on. Go look.
All right, guys, when you solve for x and you take the square root of both sides, when I take the square root of this side, I end up with y minus 1 to what power? You say that. 3 halves, right? To the 3 halves power. So be careful when you're taking the square root of both sides that you don't think of it as root y minus 1 cubed. Think of it as y minus 1 to the 3 halves. It makes the derivative so much easier, right? Okay, so we've got, woo. All right. By the way, did you find your new limits? Everyone get 1 to 5? Any question on that? Just plugging in x and finding y? Okay, so there's our derivative. And, whoa. Whoa, oh, it's gone now. That's it. There's no going back. Okay. So there's your setup, right? Integral 1 to 5 of 1 plus the derivative squared dy. You got hands up like you're done? I didn't think that was a surrender. I thought that was more of like a drop the mic kind of a thing. Right.
What?
Do it again?
You're aiming at me. I thought I was off camera.
Wait. Can you scooch like 2 steps that way? Or that way is fine. Whichever. No, okay.
Years ago, my boss kind of scolded me for using the word scooch in a business meeting.
Why?
It's not, I don't know, it's really not.
It's not workplace appropriate,
Yeah.
I guess.
Would you please step out the door?
Scooch. I was gonna fall.
This is just too hard, Miss Price.
All right, so I ended up here, which I really hope. Don't be filming students. Hey. Oh, is it dead? What's she doing?
It's up the wall.
Oh, okay. Oh, you filmed the wall.
Cause she goes, this is just too hard.
Oh, no, then you filmed the sign. All right. So someone should probably check to make sure this and this are equivalent. I'm hoping that they are.
I was just giggling.
Okay, but the main thing to recognize is that when you square something to the 1/2, that the powers cancel each other, right? And so you end up with just 1 + 9/4 y minus 1. I went ahead and distributed and combined. Remember when you integrate, you've got two options. You can either pull the 9/4 out of both terms and really even out of the root, right? Have a 3/2 out front times the square root of y minus 5/9. You could do that, and that would be fine. I just kept it in, but remember when your argument is linear and you're doing an antiderivative, you have to divide by that coefficient, right? So it's 1/9/4 times the integral of however you would just approach this if it was just a y. Which is just power rule. Remember, if it's just a linear argument, you do the rules just like you always would, just normal. But just remember, if there's a slope that's not just 1, you have to divide by it. Yes?
So you can't either use those?
What would you use as u? 9/4 y minus 5/4?
Yeah.
Yeah, you could do that. You get the same answer. Yep, absolutely. Yeah, you could do a u sub and let u equal the entire argument, and you would get the same answer. All right, that being said, are there any, I know that the integrals, it's really easy to get bogged down in doing the integrals by hand, but as far as just this setup for arc length, are you guys okay? Are there any questions? Yes, no? Where did the which? Oh, the limits? Okay. So, if we integrate with respect to x, those are x values. But since I decided to solve for x in terms of y and integrate with respect to y, then my limits have to match my variable. So I plugged each of these in for x and just solve for y. So if x is 0, y is 1. If x is 8, y is 5. Good. Other questions?
Can we go back to doing shell methods?
It's just, you know, if I made you do all the shell methods by hand, you'd be having the same kind of squabbles, right? I mean, okay. So, all right, moving on. Deriving formulas is so much fun. Let's derive another one. Okay. I like my
Let's start
rhyme.
with a blast from the past.
Let's start with a blast from the past. What is the
What'd you guys say? It's a slant rhyme?
Remember that test?
I realized that
Oh,
The
it's not a
cone.
slant rhyme?
it's a normal one.
A normal rhyme. Okay. All right.
Oh my god.
Okay. So, blast from the past. Formula for the surface area of a cone. Third period got it with no cheating.
4/3 pi r squared.
What was that?
4/3 pi r squared.
4/3 pi r squared is
1/3.
the surface area of a, 4 pi r squared is the surface area of a sphere. 4/3 pi r cubed is the volume of the sphere.
So
1/3 pi r squared is just a third of the area of a circle. 1/3 pi r squared h is the volume of a cone. We want the surface area of a cone. It's pi r squared plus, someone said slant, plus 2 pi r h, which I think is right, although I think I have it written wrong. I have pi r h.
pi r s.
Pi r s, yeah, I know, which is your slant height, right? So, anyway. All right, so we've got, we get the lateral surface area, so I've got pi r s, but I'm thinking that that's wrong because it's a 2 pi r. I have to look it up to make sure I'm not wrong. It makes sense that it would be a 2 pi r because that's your circumference, right? Times your slant height. So anyway, I think it's written wrong. I will double check. All right. Hey, isn't it fun? Last week we talked about a frustrum, right? So I learned what a frustrum was. It's a cone with the top chopped off, right? This is called a frustrum, right? Okay. So anyway, oh yeah, because there it is. It's 2 pi, right? I put the 2 pi in there. I just dropped a 2 pi under it. So anyway.
I think 2 shouldn't be there, I just Googled it, and it's IRL plus IR squared.
Oh, well then it's right. Okay, look up surface area of a frustrum.
Oh.
No?
Oh, because then you got the two circles.
I think that's where the 2 comes
versus-
from, because there's 2 circles.
Yeah.
Yes.
Makes sense.
So, and you're doing the average of the radii, and so then you double it. It makes sense to me. So I think that is right. So I think these are right, and I think this is right. So anyway, surface area of a frustrum is 2 pi big R S. S is the length, this slant length right here. And then big R is if you took each of the radii and averaged them together, the top and the bottom radius, averaged them together, that gives you your surface area of your frustrum. Okay? Now, why would we need the surface area of a frustrum? Well, if you think about it, if we're doing volumes by revolution, right? So we take some curve, rotate it about an axis. Well, if we were to take that curve and chop it into chunks, right? Then the surface area of each chunk would be like a little frustrum, right? Surface area of each of those little individual frustrums. I'm getting one head nod. That makes me happy. No? See, people can't see it? If you think about, so if I took, say I wanted the surface area of this curve, right? So if I took this first part, right, and spun it around, the shape would be roughly a frustrum, right? Right? And then like took the next part, right? Another frustrum. And you just do all these frustrums.
Oh, we're looking for three-dimensional size.
3-dimensional, yeah, that is the only surface area, yes, okay. So, yeah, so you take all those frustrums, add them together, make them infinitely small, right, make delta x go to 0, add them all together, and you get the total surface area. So that's where surface area comes from. It's the infinite sum of really tiny frustrums. So there you go. Okay, so here's our formula for surface area. 2 pi integral r of x root 1 plus f prime squared dx. Hey, what is that root 1 plus f prime squared? What is that?
That's
Arc length.
That's arc length, right? Hey, so in this case, going
Job,
back,
Rogie.
the arc length, that's like the edge of the frustrum, right? So this is the surface area of some sort of funky shape that's been revolved about an axis. The surface area, not the volume, the surface area. All right? R of x, the nice thing about these is these will almost always be dx problems. So if you're rotating about the x-axis, your radius, here's the thing, think of it spinning this way. Your radius is actually your function height, because it's coming from the x-axis up, it's spinning that way. So your r in this case is your function. If you're spinning this way, your r is your x value. Now, there's a little bit more to it. We'll talk about this in a minute when we get into the problems. So, horizontal axis, your r is your function height. Vertical axis, your r is just your x value.
You leave that at one side.
I will leave that up. Yes, Miss Simon. I can't believe it hasn't died yet.
I'm surprised too, it's still flashing.
Maybe it's flashing because it's recording. Smart.
Yeah,
No,
it could
it's
be,
got the
but
actual-
not.
It's been doing it the whole time.
But it says the battery, is it black?
Yeah.
Or gray?
No, it's black. It had one little white bar before.
Ah, I see.
It said 4 minutes. It's been like 20 minutes.
All right.
It's been like 40.
Okay, so we're going to start by finding the
Time
area of the
flies when
surface
you're having
formed by
fun.
revolving the graph f of x equals x cubed on the interval
No,
0
math
to
is
1,
fun.
first about the x-axis and then about the y-axis. I had a discussion with Mr. Thomas right before class, because a question or concern came up during third period where if you're asked for the surface area, say you take this shape, right, and you're revolving it, you know, about the x-axis, so you get this kind of a thing, right? Anyway, that kind of a thing, right? Like kind of like a horn, right? So the question was, does the surface area include just this area of the curve that's been revolved, or does that also include the area of the base, right? Because there's a circle on the bottom, right? And the answer was, right? So it was really very vague, and it was vague in every respect, like in your homework, your quiz, your test, the AP exam, does it include it, does it not? And so he said, well, if it says total surface area, then you should probably include the base. If it says just the surface area of the surface formed by revolution, then they just mean that surface, so not the base. So for,
If it's like an application problem?
then you would have to know based on the context, probably. Yeah. So anyway, it was an interesting question. So for now, unless it says total surface area, we're just going to kind of assume that it's just the surface that's formed by the revolution part, right? And not add that circle on. If you aren't sure on a quiz or a test and you add the circle, I'll probably take it either way, if the question's vague enough to not specify, right? So, anyway. All right, and you have that on film now, right? So there you go. What'd you say?
What if it gets deleted in the battery?
Oh, that's true, then you're stuck. Okay, all right. So, here we go. So first we're going to revolve it about the x-axis, then we're going to revolve it about the y-axis, and I'll walk you through these, and then you guys will try one on your own that's very similar. So, about the x-axis, so we have a horizontal axis, and if you think about your radius, right? Think about the way the frustrums are. They're going